Welcome to my whiteboard videos. In this video I'm going to show you how to compute the areas under the standard normal curve. The standard normal curve is a bell-shaped curve with a mean of 0 and standard deviation of 1. Let's look at the first example right here, where we need to calculate the area to the left of z equals negative 1.23. As you notice, z is to the left of 0 because it's a negative number, and we need the shaded area. Okay, area to the left of z equals negative 1.23. It's nothing but the probability of z being less than negative 1.23. So if you want to convert an area to a probability or area under the curve, you can write it equals probability of z less than. If it is to the left of z, it's a less than. If it is to the right of z, it's a greater than 1.3. Now, in order to calculate the probability, you have two ways to do that. You can either use a table or you can use your calculator. If you are using the TI-84, you can use a feature which is called the Normalcdf. Normalcdf. Okay, the Normalcdf requires 4 arguments. The first argument is a lower bound. The second one is the upper bound. And then we need the mean, and then we need the standard deviation. Now look at this area right here. What would be the lower bound? The lower bound, you know what bounds this area from the left. As you know, this tail extends indefinitely, so there is no bound. So if you want to use a very large number from the negative side, that would be negative infinity. But for the sake of using the calculator, instead of putting negative infinity, put a very large number but with a negative sign. So I would suggest let's put a negative 1,000,000 here. You can put negative 1,000,000,000, etc. That should work. An upper bound. Okay, what bounds the area from the right, which is the right bound right here? Well, it ends right here, which is negative 1.23. So my lower bound will be negative 1,000,000. Then my upper bound will be negative 1.23. And since we are using the standard normal curve, this is 0 and 1. If you go to your calculator, you can press the second key, then variables, then go to Normalcdf, and enter the following arguments: negative 1,000,000, negative 1.23, 0, 1, and you should get an answer of 0.1093. So this is how you calculate areas to the left. Now let's learn how to calculate the areas between two z-scores. So I'm going to go to the next one. We need to calculate this area. It's between z equal negative 0.83 and 0.71. Okay, if you want to convert this to a probability, this is nothing but the probability of z between negative 0.83 and then 0.71. Remember, the sum of all probabilities under the curve is 1. So we need this probability. You can use the Normalcdf feature. Normalcdf. Okay, we need a lower bound and an upper bound. Well, it is obvious that the lower bound is going to be negative 0.83. All right, negative 0.83. My upper bound is going to be 0.71. And again, the mean is 0 and the standard deviation is 1. And if you input this into your calculator using the Normalcdf, your answer will be 0.5579. I'm rounding to 4 decimal places. Now let's go to the next one, which we're going to learn how to find areas to the right. Okay, for the area to the right of z equals 0.92, we want to change this to a probability. That will be a probability of z greater than 0.92. As you can see, it's an area to the right. Okay, probability of z greater than 0.92 would be equal to, if you want to change it to normal CDF, okay, what would be the lower bound? 0.92. What would be the upper bound? It's just like the finding the areas to the left. The upper bound here, it extends, the tail extends indefinitely. So you need to use a very large number, but from the positive side. So I would suggest 1 million here, or 1 billion, and then 0 and 1. And if you do the math using your TI-84, you can use the table provided with your book. That would be 0.1788 rounded to 4 decimal places.